So again, what happens when you calculate your straight development length and you don't have the distance, you don't have the length available to you. You got to do something. You know, your straight bars, you know, the length, if your formula for the straight line development length came out to be 24 inches, but you only have 18 inches of footing depth, you got to do something. What is it that you're going to do? What you're going to do is you're going to end up using a standard hook. All right? Now, I will refer you to your book because your book has pictures, and all concrete textbooks have pictures of standard hooks. Okay? This is one of the great misunderstandings in concrete rebar design, concrete rebar, even fabrication or detailing of this. We use typically, there's different types of hooks, but the two most common are the 90-degree hook and the 180-degree hook. And your book has pictures, all books have pictures of what these standard hooks are. All right? One of the great misunderstandings is we just got done talking about straight bar development length, and you sort of have, you know, an idea of what that's all about. You know, I'm stabbing this bar back into a wall a certain distance so the wall can hang on to it. I'm stabbing this bar down into footing a certain distance so the concrete can hang on to it. A lot of people think the way a hook works is that you put it back into a wall or footing or column or whatever, and it works the same way as a straight bar. That's wrong. People want to say, the hook, this hook, people want to say this and they're wrong. This hook gains its strength because all I'm doing is taking the straight bar development length and I'm just redirecting it. So if I needed 48 inches of length back into a wall, I'll just, you know, this just needs to be 48 inches. Wrong. The hook is the hook. You can look at pictures of the hook and the standard detailing of the hook, but like a 90-degree hook says, take your bar back and you go through the bend diameter and you go 12 bar diameters past that point. So from the radial point of your bend diameter, you go 12 bar diameters. That's the end of the hook. You know, you go from here to there, 12 bar diameters, and that's the end of the hook. You can go another 9,000 bar diameters past that point. Does it get you anything? No. This is the hook. A lot of people, they have this misconception that, man, if 12 bar diameters is good, 36 bar diameters must be great. Or 136 must be out of this world. Not the way it works. The hook is the hook. Because the hook doesn't work the same way as a straight bar does. The straight bar works almost like, like tug of war. You know, you're pulling on a rope. You know, I mean, you're gripping onto that rope while somebody's trying to pull this rope. You know, the longer length that you're grabbing onto that rope, you know, the more grip you have on it. The hook doesn't work that way. The hook basically says this, you know, I'm going to gain my embedment because if this was a column, in order to pull out this hook, what's going to happen? this whole chunk of concrete is going to have to blow out. You know? It's not going to come out by pulling this bar out and somehow making it straight like it's coming out of the tunnel. That ain't going to be the way that this fails. Your straight bar could fail that way, sort of. I mean, it'd be a pull-out failure. But this is much more mechanical thing. This would be like this. You know, we talk about the falling off a building in the movies and somebody grabbing onto your arm or your whatever. Okay? If you were trying to save somebody from falling off a building, would you rather grab onto their arm with your hand, okay? Or would you rather grab on to underneath their shoulder with your elbow, shoulder, your whole self? Would you rather hold them with your hand, them dangling, and you holding on to their arm with one hand? Or would you rather hold on to them because you have their shoulder locked into your elbow and your shoulder? If you had to wait there for a minute or 2 minutes while the police came to help you out, how would you rather hold that person that fell off that building? Yeah, locking the elbow joint. That's this. Yeah.
The amount of concrete in between the hook and the face of the beam, does that when you calculate that, is it 100% of the area of concrete, or is it more? Is it stronger than because it's got the hook? Or?
Well, actually, and that's interesting, because if this is almost like a mechanical anchorage now, we really our development length. Now, this is the other odd thing. When we calculate our development length for the hook, you know what we're calculating? Now, hang on to this. This is interesting. We are calculating the straight distance from the beginning of the hook to the turn of the hook. So we actually, the length that we calculate in our formula for hooks is not this length. It is this length. So yeah, so what, practically speaking, if that length is longer, is there more concrete in front of us? Yes. But we're not really calculating anything other than a straight line, okay? Which is sort of different.